So today we are going to present our project ElevateEase, a multi-model elevator interaction experience. This is Yisong Huang and with our teammate Jiahui Zhang, Feng Guo, Fei Lian Dai, and Yanxi Liu. All right, today we're going to talk about our motivation, related work, user study, and our product ElevateEase, and also future work. So, first of all, we're going to talk about a little bit on our history on the elevator. So, the elevator is being built by for a long, long time before. So, first of all, is in Greek engineer Acme was designed a vertical transportation device. So we related with the elevator, we have a lot more conveniently live and also it help on our experience for anybody. So our project was inspired by all bad experience that we having using elevator in daily life. Those experience which is include being crammed in a crowd elevator during rush hours, which is mean we are unable to press the button for the deserted floor and then or we have some trouble like with recognizing the floor indicator. Also, sometimes in a large shopping mall, we can't find which floor we're going to. So it will be making a lot more not necessary delay. We're going to create a product that can improve the experience. So in our project, we hope to improve our user interface for the elevator system. It can be making more efficiency, intelligent, and user-friendly by introducing our modern advanced human-computer interaction technology, such as a speech recognition. So our goal is to make the elevator is more useful, more comfortable, and more conveniently that can improve the user experience for multi-group of people. One of our majority goal will be improving for the accessibility for the elevator system, which just mean our project will work to ensure the elevator system that can be served for all users, including those with different medical condition or other special needed, because the periphery access is often is very special requirement. So our project will be presenting a perfect multi-design for suit for all the user in the crowd.
So let's talk about reading work. So we actually do a lot of literature review on this view. So like we actually start in the elevator everything, the software design and in the interface stuff like that to help us to build a basically understanding here. And we actually have the user study from two parts. First is the questionnaire. Actually build a questionnaire and send to as many people as we could. And you can see here. And second is that we have observation methods that actually we have a guideline for our team member to observe people in real world situation, like which them push button on the elevator. So here is the data analysis for our questionnaire. We can see the most feedback about the office building because most of our users are students, and many of them like have some more advanced features like touch screen or like voice control stuff like that. And we have some feedbacks about the difficulty when they are using elevator. We can see like the button is too tight, stuff like that. And here is our observation date. We can see we actually went to three spots on grounds, like the old cable, rice hole, and Siemens library. We have like data like number of people, need for assistance, room floor selection, stuff like that to help us to build more understanding. And you can see like for the first and second part, that people are make some mistakes here, while the Siemens has less mistake due to its clean design. And this all help us to build better understanding on this.
Here is our formative study part. In this part, we show our group's discussion, activities, and how we continue to update our project progress and plans. First of all, in order to improve efficiency, our team used Zoom meeting to ensure that every member can participate in weekly discussion. This is the picture of recording our group's weekly discussion meeting. We will record everyone's idea or questions on whiteboard function, share them with other group's members, and discuss some modification suggestions. And in this progress, we discuss the details from the beginning to determine the specific plan. And in the later implementation plan, every member of our team activities participate in the analysis of previous data and improve our final projects and results. And in this part, we'll mainly show what we use to build our user studies. I'd like to introduce you the Swift design platform we use to validate our multimodal interfaces, which is on the right. And we also use Unity later to try to be more realistic instead of just using the interface. Therefore, we made the model in Unity and added elevator logic to help user test. And in this part, we conducted a test, but the effect was not very good. So we will introduce our data analysis later. However, after discussion, our team still hope to have the opportunity to develop a VR version of the test because this will be more conducive to testers' in-depth participation in our tests. And here is our evaluation method part. Our goal is to determine the difference between a traditional elevator button interface and a multimodal interface with voice control and an electronic screen. And we have three experimental parts. The first one is we use A/B testing to determine the difference between a multimodal interface and a normal button interface. Also, we have voice control system accuracy and elevator availability analysis. For our metrics, which are test completion time, number of buttons, and error rates. And for the analysis model, which is ANOVA model.
So in this section, I will talk about the results of our experiment and the analysis of the data. So the first figure represents our analysis of the time on the task and the number of the button. So where A and B represent our traditional visualization interface and the multimodal interface we create. And I and O in the mission code represent task to a given floor and the tasks given floor and back to the first floor. So the first graph clearly shows that the average time spent on our multimodal interface is less, while the second bar graph shows that we can reduce the amount of the button used in more complex text. But there is not a lot of advantage in the simple text, which is task I. And secondly, we performed a NOVA test on the data. It was clear that all our tasks were not significantly different, and also we analyzed the data so that there are some situations that cause the participants to appear uncomfortable with the new interface. So finally, we also analyzed the other metrics such as the number of the button we pressed over here and such as the wrong button we pressed over here. So we found a significant difference between A and B in the number of the buttons in the complex text, which is the O text. But there is no significant difference in the button errors. So in this section, we will focus on the analysis of the accuracy of the speech system and the usability of the visualization interface. So the first, we test the speech recognition effect in the quiet and noise situation. But there is a very obvious difference. And at the same time, we also analyzed whether the usability for the different people change in the different UI design situation. However, due to the small amount of the time and the number of the tasks and the fact that most of the participants were young people, so we were able to draw very significant conclusion about this situation. So overall, our design did reduce the number of the button press and increase the speed. But although the increase in speed was not significant, and also at the same time we found that our speech recognition system still need to improve its accuracy. So our post service found that many of our participants dislike the use of the speech. So mistake was always made, but no one want to try again. So this is our conclusion of our group, and yeah.
As for future work, we are transitioning from iPad-based animations to VR simulations for a more immersive experience, aiming to improve both user engagement and data reliability. We are also expanding our test audience beyond university students to include a diverse range of participants, enhancing the relevance and the applicability of our designs. Lastly, we are moving testing out of schools and into real-world settings like supermarkets and airports to better understand how our products perform in everyday scenarios. These changes mark a significant step forward in making our user testing more comprehensive and effective. Thank you, and I look forward to your questions and insights.